Hey, welcome back. In this video, we're going to discuss probability, specifically probability with compound events. That's more than one event. They can either be independent of each other or dependent. Let's get started so you can see what I'm talking about. So probability really is just multiplying fractions. It's just chance. So it says you have the letters A, L, G, E, B, R, A in a bag. What's the probability of pulling a G? So that means I want a G the first time. I will replace it, and then I want to know what's the probability of the second draw to be an A. So what I suggest is figure out your total, because your total stays the same on both. This is independent. The fact that the G was put back in, my total doesn't change. There's 7 letters, so that means my denominator or my total will be 7. The first thing I want is a G, and then the second I want an A. Well, you got to look, how many G's are there? There's just 1. How many A's? There is 2. So you just multiply straight across like you've been taught, 2 over 49. That's the probability. Now, you could have to convert it to a decimal or convert to a percent, depending on what your teacher wants you to do. 2 out of 49, it works for me. All right, so let's go to the next one. You can flip a coin and roll a dice. What's the probability the coin lands on heads and the dice lands on a number less than 3? So when you flip a coin, that does not affect what happens to the dice, which makes it an independent probability event. So the coin is either heads or tails, and then the dice is going to have 1, 2, 3, 4, 5, 6. Because we're visual creatures, I like to just kind of write it out. The first thing I want heads, so that's 1 out of 2. And then the probability of getting less than 3. It didn't say 3 or less, it said less than 3. That's only 2. So that would be 2. And the total from the dice is 6. You'll multiply straight across. You don't need a common denominator. 2/12, which simplifies to 1/6. Now, if you had to convert to a decimal, then you need to check out videos where I have fraction conversion to a decimal or, fraction to a percent. But for this, we're going to leave it like this. All right, here's the next one. This seems to be the ones that's the biggest deal for kids. Even when I started teaching many years ago. There are 4 blue marbles and 2 red marbles. Marbles selected, it's not returned. So that means that's going to affect the second event. What's the probability that 2 red will be chosen? So I like to list it out. It would be blue. Now, this is not a teaching method. I just think it's helpful to see this. So my total is 6. But keep in mind, not replaced, that means the first total is 6 and the second total would only be 5. So the first time it would be a red. There's 2 reds, so it would be 2 out of 6. However, theoretically for the second one, there's only 1 red. So it'd be 1 out of 5 because it said 2 red marbles. So you have to, your probability of the first one was 2 out of 6, and then the probability of the second time is just 1 out of 5. We're going to go ahead and just multiply it to 30, simplifies to 115. Hopefully this just reiterates what you're learning in class. This is how I wouldn't teach it. I'd go more into depth. All right, so here goes another one. Madeline places the letters in the word December into a bag. So now let's count our letters. 1, 2, 3, 4, 5, 6, 7, 8. So our first total is 8. All right, a letter will be randomly selected, not replaced. Not replaced or without replacement. That tells you that the probability is dependent. So another letter will be selected. Okay, so we've got some information. What's the probability that she selects a C? So C is the first time, and then the second time is E. Well, lucky for us, there's only 1 C, which is great. And then we take 1 out of the total, so now the total becomes 7. And now, how many E's are there? 3. So Remember, probability is favorable, which is what you want, and it's out of the total. So this would be 1 times 3 is 3. 8 times 7 is 56. Oh, man. I don't think we can simplify it. I'm going to say we don't. If I'm wrong, obviously, I'll re-record the video. All right, so that's it. We've got a couple of probabilities on dependent and then a couple on independent. Hopefully this helped. Thanks for watching.